Hello everyone, welcome to our another virtual meetup. Today we have connected with a special guest, Eric Oslo. He's a software security expert and with a very extensive uh, Java experience. He's joining us from all the way from Connecticut, USA. Welcome, Eric. How are you doing?
I'm doing really well now that I can find the unmute button.
How's the weather over there?
I mean, it's kind of nice today. We got it starting to get cold and not too hot. So it's super nice because I got all the windows open.
Yeah, it's same over here. It's sunny over here. So beside we have Mr. Aruna Abdullah Al Mamun. He is also a JAG leader. He's currently working at Global Relay. He is going to help us to today's session. And I'm your host, Pozri Rahman. I work at Loblaws Digital here in Canada. Yeah, that's all the introduction. I guess we can start without further ado. Let's start. Eric, floor is yours.
Sounds great. All right. Are the slides coming through? There we go. I see it right now. I like this platform. All right. So now we're going to go through and we're going to talk about securing and exploiting Java applications to figure out ways that we can that our applications are being attacked, and then figure out a couple pragmatic steps that we as our engineers can do to secure our own applications to just get better at security monitoring and also active defense. So the first thing that I want to do is to talk about the way that we got the conversation today. We're doing this as a part of the Fujay Jug Tour for JDK 17 release, and Fujay is Friends of OpenJDK. It's an open community that anyone is welcome to join. There's a number of companies that operate in it, Azul, Datadog, Hazelcast, Pyara, a large number of others just have gotten together to create this nice, friendly community to chat. There's also a lot of articles that are written by different experts and project maintainers. Some of them syndicate their personal blogs to it. Some of them don't. There's also a nice Slack to just talk with different people. For me, the thing that I get out of Fujay is it's just a cool way of talking to other people like Basler and Arono. Always nice to make some new friends. I get to talk with people who make different projects. And I've also kind of ended up becoming the host of the Fujay podcast, which just gets a lot of engineers on and is just kind of fun to do. And to introduce myself, I come from originally a software engineering background where I was an engineer who sat there, wrote code, architected some systems. Then after doing that for quite a while, I said, you know what, it'll be fun. I really like the security angle. So I started to do security consulting of talking about the little shortcuts that I would take in code and ways that I would or wouldn't do different projects to defend. And I also knew how to break into different systems. So it was just kind of interesting. And I did consulting for a number of major financials for a while. And that went well. So I ended up taking over product management for the static code analyzer product that we had that picked out security flaws. After doing that for a while, the core Java platform was under attack, and I just looked at it and I said, look, if I understand security issues like I think I do, then I can go join the core Oracle team at the heart of the JDK and help with the security of this platform. That was in the Java 7 to 8 2013 timeframe. And we did pretty well. There was about a 2-year absence of zero-day exploits in the core platform. And since then, I've gone on to do cloud migrations. And right now I'm at a company called Contrast that does integrated security inside of applications. So we add security sensors into the JDK, not into the JDK, but into the different libraries to just pick out crucial information so that people can find security flaws in their applications. Otherwise, I'm one of the tech editors for a news site called InfoQ that covers cloud machine learning, and I'm specifically in the Java queue writing articles about different Java libraries. And I've also got some courses on there, like the most popular one that I did is hands-on cryptography with Java, which is both educational and me making a lot of jokes about cryptography. All right, so the way that I want to talk about security of Java and your applications today is step one, I want to talk about how Java applications are being attacked. I'm going to talk about some actual exploits that are going around right now or have gone on in the past, and we're going to cover the ways that people are attacking these applications, and you can relate it to your own application. Then we're going to talk about what's happened in the Java platform recently and enhancements that have gone on between Java 8 and Java 17 that you can use or that you can just leverage in your software. And then we're going to talk about some more proactive steps that you can easily do inside of your application so that you can leverage the things that are in the core Java platform, as well as some other techniques to get a better defense of your application. Now, a lot of people look at me for quick opinions and they say, oh, are we going to get some kind of dirt on this? Is there going to be some security things? I just like to look at things and comment on what I see. And what I see in the overall ecosystem is that the core Java team, the people who maintain the JDK and the OpenJDK community, are doing a pretty good job in terms of maintaining the security of the platform. I think they've got a really nice cadence of a lot of things. They seem to have a lot of materials together, and they've done a lot of really good work. So what I've noticed in the last couple years is that there's no more real risk of, is Java a risk? Is it risky to choose Java? Is there possibly something wrong with it? The answer is no. It's quite a good platform. And what we're finding on the security side is that security is more about the context of what data do you have? How does your code interact with that data? What libraries do you use? Do you have vulnerabilities in those libraries? Have you upgraded your libraries recently? Do you have risk? So what that means is that the core Java JDK itself, there's the risk there, there's less of it, and it's far more manageable. And now we get to focus on the core of what we do ourselves as engineers in terms of the applications that we're creating. So with that, I want to go and I want to talk about some active exploits now and some exploits in the past so that we can get a good understanding of how our Java applications are being attacked in a relatively hostile internet that's crawled regularly by different hackers using dynamic scanning tools or just crawling around looking for vulnerable applications. And when you go to look at how applications are being attacked, one of kind of the nice and bad things about being in the security industry is that you don't have to look very far for something to be going wrong. So even when I started putting this presentation together, I said, well, what exploit am I going to use? And right then there was an exploit going around that was attacking Atlassian Confluence through a Java library. And it's actually so bad that the U.S. Cyber Command, which is part of the United States Department of Defense, just a amalgamation of different military groups coming together to talk about software systems, has gotten involved to issue some warnings against the application in order to tell people to patch it. And I'm going to read the comment here by the Chief Information Security Officer of the Air Force, simply because his words are pretty strong. And I like people at Atlassian. I think they're a nice company. I think they're really good people. But I'm just going to read what the CISO of the United States Air Force said about this attack on Confluence and the way that it attacks a Java application. I continue to be baffled at the poor security practices of Atlassian. Literally the worst cybersecurity posture I had to assess for Iron Bank containers. I've been pushing them to upgrade 6 to 12-year-old stale dependencies for a year and a half with very little luck. Allegedly, the vulnerabilities aren't in the code path. 6 months to update according to their SLA. That's no excuse. Wake up. As they are now listed as critical software for Department of Defense, hopefully the President's Cyber Executive Order will require them to step up their game or be de-authority to operated. Unfortunately, they don't feel any pressure due to the monopoly they have. This CVE, the vulnerability in Atlassian, was critical and we were immediately impacted overnight. They don't even notify their customers. I can't really think of anything I've seen in 22 years that is worse than this kind of behavior. That's a relatively strong statement. Don't normally get statements that are that strong about a standard vulnerability, but it demonstrates the impact that some software can have in an industry and the impact that can be had on that software when it's found to be vulnerable and pose a risk to those who run it and need to rely on it. So the way that this application vulnerability is working is people, when they go to attack a Confluence system, they're attacking it through a library called Commons OGNL, which stands for Object Graph Navigation Language. And this is something that developers will commonly add to a web application in order to gain access to some scripting capabilities, because it lets you write different web front ends a little easier. And there's a link right there, and you should have the link in a YouTube presentation. It's in the deck, which I believe is there. And you can see they actually did a thorough write-up of the way that this vulnerability is manifesting itself through Atlassian Confluence and into the Commons OGNL library. But basically, the way that it works is there's a query string that comes in from a remote user that's UTF-8 encoded, where you can see the query string equals AAA \0027. And you can see some materials there. But when you decode it, what you get is query string equals an OGNL statement, pound open curly brace. You see that class.for name. They go after java.lang.runtime. We all develop systems. We know what's in there. Runtime has a command called getRuntime.exec, which will literally run a shell command on the system. So what these attackers did was they caused it to just open up a curl command to communicate back to something that they have. Now, what you see in here is they're calling curl, and then they open a specific instance of burp collaborator, and that tells them when something has made a remote connection. But you can pass any command that you want into this string, and because runtime get runtime exec is a static method that takes a string, you'll be able to execute virtually any shell that you want on that system. So what we're seeing here is there's no vulnerability in OGNL. OGNL is perfectly safe to use. It's great. I hope some of you who use it are enjoying it. But it becomes unsafe when you combine that powerful scripting library with remote data that comes from an arbitrary user on the internet. So these things become very unsafe to use when you take the remote input and you pass it directly to a code execution function. So the reason Atlassian Confluence is vulnerable is they took data and they passed it directly into OGNL to execute. They did try some sanitization. You can actually read in the write-up about how the attackers went through to just bypass all the validation and still execute shell commands on Atlassian. Anybody who uses Confluence, please take the latest updates that they have. All right. Now, I like to go through a couple different things. I don't want to just say there's only one vulnerability. I'm going to go through a couple different types. And we just talked about the Atlassian vulnerability in Confluence that's going through Commons OGNL. Another type of vulnerability category that I want to talk about is deserialization flaws, because those have been prominent in a number of Java applications for a number of years. And they've actually made it into prominent industry attack reports like the Verizon data breach report. And then there's a third vulnerability that I'm going to talk about a little bit later. And if you squint your eyes, you might be able to see what it says under the hood there. But I'm going to cover that vulnerability more in the part about the JDK improvements. So deserialization, which occurred in WebLogic and a number of other Java applications, is it's part of object input stream, where what you do when you deserialize some data is you effectively do your JDK effectively does three steps. The first is somebody sends it some data, or it gets the information that the Java application needs to read. It then goes through and it says, how do I read this object? And you've given it some nice instructions. So then the code that you write, simply reads these instructions that the user sent it. And it says, all right, I'm going to reconstruct this object. I'm going to put it back together so that I can operate. And step 3 is you realize that they weren't actually instructions on how to deserialize the object. They were instructions to take over your computer and give somebody access to your server on the back end. So this vulnerability category has been going on for quite a number of years. There's a nice InfoQ article that I wrote back in about 2018, and I was kind of late to the game to write this article about the state of Java's deserialization, where we cover just what the different types of vulnerabilities are in the Java platform, how people attack serialization, how the JDK deserializes objects, and what the risk is. And if you're looking at deserialization and you're thinking, how do people attack this? There's a lot of different tools that researchers and pen testers use. The most common one that I see to attack the libraries is a tool called why-so-serial. And what why-so-serial does is it just has a number of payloads and gadgets in it that attacks different Java libraries. So you can attack things in Spring, in different libraries, and you could just attack different classes and payloads. And it gives you a nice thing that says, take this object here and pass it into the web application, and you should get a remote shell on it. So what you do is you take the output of why-so-serial, you pass it into an application, and if that application is vulnerable, you've got a remote shell on it. And if some of you are thinking, is this just a Java-specific library? Are we the community that's having all the fun? I have a link in here to the why-so-serial tool that you can use to test your own Java applications. And just because I don't want to leave others out on the fun, I've also got a link to why-so-serial.net, so you can send it to your friends who code in .NET as well and realize that this is not a Java-specific problem. It just happens to be in the mix of data and code. Otherwise, a lot of people I talk to, they say, well, you know what? I don't use Java deserialization, so I don't need to worry about that. Jokes on anyone who thinks that they are in that camp, because a lot of libraries actually go through and they use Java deserialization, even though you might not know. So here's 3 common libraries that a lot of people use: Xstream, Struts2, Jackson. All of these at some point have had a deserialization vulnerability in them. And they've all done a really nice job of patching and notifying their users and telling people about when it's time to upgrade their libraries. But the gist of the matter is, even though you might not use Java deserialization yourself, it's probably a part of one of the libraries that's in your stack. For example, the most common one that used to be taken over in these systems was just the notion of a collections library. So Apache Commons Collections is the way that WebLogic was hit with its deserialization vulnerability that was mentioned in the Verizon data breach report and has actually been used to compromise a number of companies. And if you want some more details about how Java deserialization works, how it's attacked, I've posted a link in here to a Java deserialization cheat sheet that you can use to just go through and gain a really good understanding of the way that different people are attacking this. So whereas you can use why-so-serial to attack something, it's always nice to know how it works. So feel free to look at the Java deserialization cheat sheet here, and you can see the way that people are attacking them and why they hunt for certain aspects of information. Otherwise, there is a feature in the Java platform that was designed to defend against deserialization attacks. And I know each time I mention deserialization vulnerabilities, there are some people who chime in and they say, oh, but that's been dealt with. We have a capability to do that. It was in JEP 290. It was introduced in JDK 9. You see release 9 over there in the picture. Well, this is, you can use Java serialization filtering mechanisms to help prevent deserialization vulnerabilities. These things are great. It's nice to have these active defenses, but when we go to actually look at this capability and apply it in practice, it turns out that the feature is there, but at least for a long time, it wasn't really usable in a way that people could actively use it as a defense. It was nice to show that the feature was there. The feature was designed to defend against deserialization vulnerabilities, but it was very difficult to use, and I don't think I'd ever actually seen it used for a long time. So you might know about this, but I doubt anyone at this jug is actually using this as a defense, and we'll cover why later and how that's been addressed. Now, with these 2 types of vulnerabilities, with the OGNL and the deserialization flaws, what's common in them? What's the thing that we as developers need to look at to make sure that we're actively defending our applications well? And the common risk here is there's custom code that exposes some level of functionality. In the case of Atlassian, it was their custom code and the way that it passed data to OGNL that introduced that vulnerability. The other aspect is libraries and the JDK that have known vulnerabilities. So in this case, there was in the WebLogic one, it was the Commons collection library that was occurring underneath it. So one of the things that we need to do when we go to secure our applications is to look at the custom code that we write as well as the libraries that are underneath us. We need to make sure that all of those things are okay and that the interactions between them are good. Otherwise, if all we do is we say our libraries are secure, all of Atlassian's libraries were secure, but their application wasn't because they passed data in a very unsafe way. So now I want to go through and talk about some improvements that have gone on between Java 8 and Java 17. And if you'd like to upgrade, why you should do that so that we get a handle on how the teams are addressing security vulnerabilities and giving you tools to improve the security posture of your application. So one of the things that's been going on since about Java 9 is a significantly decreased attack surface of the JDK itself. And what they've been doing in the JDK through modularity or through Jigsaw is to go through and take different types of threats and put them in these nice little boxes so that you can quickly look at an application and figure out what parts of it uses, and then be able to box those things in to figure out what the different threat types are. And now that there's no more applets, there's no way for anything remote to make a call into the core JRE. So the risk to an application is literally exactly what you expose. And the fact that code is segmented into modules makes it very easy to slice out what parts of the application you're using so that you can know what your overall attack surface is. For example, the java.xml module, there was a vulnerability category called XML external entity injection, where you could just read arbitrary files off somebody else's system that would be included in the XML document that they read. Really nice way to attack people. You could typically steal like the Etsy password file, or you have XML bombs. You can look at an application now and figure out very quickly, does it use java.xml module? And if it doesn't, then you know that these vulnerability categories are effectively moot. Same thing with java.compiler. If you wanted to attack different web servers, different Tomcat systems, JBoss, Payara, whoever, if they included java.compiler, it was a possibility that you would be able to inject JSPs into them, because the application would compile any JSP that you gave it, if you could give it in the right way, and it would compile that to a class file that it would execute. So you can look and you could say, does this application use JSPs, or can I get rid of the java.compiler module? Same thing, another vulnerability that's common in the software industry is SQL injection, where people are able to take over the SQL queries that you use to either extract other data, or if you use something like Microsoft SQL Server, there's a command called xpcmd shell that you can use to execute code or execute commands on the SQL server that attackers regularly go after. But you can look at an application and you can say, if the application does not use java.sql, then SQL injection is probably not a key concern of mine, and I should not focus on it. So modularity is nice because it really focuses on what the threat model of that application is, and we can also tell what the threat model of the application isn't. If you don't use java.xml, you shouldn't concern yourself with XML vulnerabilities. If you don't use SQL, you shouldn't concern yourself with SQL injection. You still can, but I would spend a lot less time there. Another major improvement that's gone on is security events are now visible in tools like Jdk Flight Recorder. So Jdk Flight Recorder is a low overhead performance monitoring tool that you can use to look at the JDK and figure out how it's executing. You can gather all kinds of really impressive, really deep statistics through Jdk Flight Recorder. It's one of my favorite tools in the JDK. I really like this tool. I wrote a bunch of limericks about it in a silly Java competition, like a March Madness face-off bracket last year that was really fun. But one of the things that you can do with Jdk Flight Recorder is you can actually monitor things like deserialization events. So what you get from this, in addition to the detailed statistics about garbage collection, about class collection types, about performance overhead, you can monitor security events. So Jdk Flight Recorder will tell you data when you do a deserialization, such as what classes are you deserializing? What's the code path that went through to do this deserialization event? And it's a really handy way of extracting crucial security information from the JDK. I wrote an article a while ago in FoodJ called the SolarWinds attack for Java developers that covered a major hack that went on in December of 2020. And I talked about Jdk Flight Recorder as a way of analyzing those events. And since then, the feature for Jdk Flight Recorder to actually get better statistics has gone on. So Jdk Flight Recorder is an excellent tool. And it actually makes up for the gap that I was referring to earlier in JEP 290. So JEP 290 allowed you to create a serialization filter where you could say, these are the classes that I'm going to permit you to deserialize. But the problem is nobody knew what they were supposed to put there. What classes do you deserialize? I don't know. Maybe this one, maybe that needs that one. Like, the truth is none of us knew the answer to this question, or very few of us did, or so few that the feature was not really complete because people couldn't use it. So now if I want to go through and I want to create that JEP 290 allow list to specifically allow list certain classes to be deserialized, I can just watch my application running and I can have Java Flight Recorder or Jdk Flight Recorder report that data back to me to track them. Same thing if I have a library of mine, like if I don't know that Xstream is under the hood there, or Commons Collections is deserializing things for me, which a lot of us don't, because I don't know what all my libraries do all the time. I don't know the specifics of them. I can have Jdk Flight Recorder extract all this intelligence for me. And it's not that hard to use. There's a couple different steps here, and you can look up the individual steps here. Just find a tutorial on how to use Jdk Flight Recorder either in dev or in production. Either is fine. The production overhead is really, really low. You just test and you use the application. You have Jdk Flight Recorder record for a little while. It gathers the details about what classes you're deserializing. You then put those into an allow list, and then you just use your allow list following the instructions for JEP 290, that deserialization filter. And then you just keep patching your JDK as normal, and you've restricted yourself to only deserialize certain classes. So what that means is the risk of those classes is still present, but the risk of other classes, like if I'm going to launch an attack through why-so-serial and it's something that's not on your allow list, you're invulnerable to it because you're not going to deserialize that class. All right, now another thing that's gone on, and this actually just happened in the Java 17 timeframe, is they've started deprecating the core Java Security Manager. That's the Java Security Manager that was typically in place to defend against applets or other application types. And that's now being deprecated. And I want people to just understand what's going on there, that first, deprecation does not mean removal. Removal is a relatively long process where things are marked as deprecated. Then there's a couple steps in, you have a couple different JDK releases, and then it might be turned off by default where you have to turn it back on. But a thing to mention here is if you don't use the Java Security Manager now, don't start. Don't go there and say, hey, now that it's being deprecated, it's time to, rush after this thing and start using it. Don't do that. Find some other defenses. And if you do use the Java Security Manager, find something else to do, which we'll talk about a little later, that you can use to gather better security intelligence or defend your systems. And if you're using the Security Manager for some sort of sensor basis, like you're trying to gain an understanding of the security actions that your application does, use Jdk Flight Recorder. Gives you a lot of really good intelligence in order to understand how that application is being attacked and what it's doing. In addition to your performance monitoring, outstanding security intelligence. The other thing on the Security Manager is that the usage of it is relatively low. There are some people who use it. There are some people who do it. But in the United States, I've been making the analogy that the Security Manager is to Java what Radio Shack is to the mall. Because here we used to have a store called Radio Shack that you could go to. They sold various types of electronics tidbits. You could go there and buy like a bag of LEDs. If you wanted resistors, you can't buy those at a regular electronics store. You got to go to the specialist store. But what happened there is nobody went to this store to buy anything. Everybody liked the idea of it. We all thought, wow, what a cool place. You can go there. You can get your nifty electronics. You can go and buy these things. But very few people were shopping there. So Radio Shack turned from kind of a store that sold things into like the place that everybody said, oh, they're still around. you remembered it fondly. It represented the concept that you could build something. If I buy this bag of LEDs, if I buy this bag of resistors, I could totally build a robot or something. But the truth is, nobody was doing that. There weren't enough people who were actually shopping at this store to be able to sustain it. So the store for a while, they all had to close. They all had to go out of business. If you'd watch a Radio Shack store, or if you knew somebody who happened to go to one, they were just all closing all across the way. I think the store, they definitely declared bankruptcy at least one time. I don't know why you can declare bankruptcy multiple times, but I guess you can. But anyways, the fact is, the security manager is a tool that's difficult to maintain, and there's not enough usage of it as an active defense in order to justify the maintenance of it. Now, that last vulnerability, beforehand, I talked about the Confluence vulnerability. I talked about the WebLogic deserialization vulnerability. The last one that I had hidden there was a security manager bypass. Because even though the security manager is in place, and even though it's present, still in 2021, you see the link there, CVE-2021. That's the year that the vulnerability was discovered. Somebody found yet another way to go past the security manager. And even though Java was running in a security sandboxed environment, they'd found a way to break into that application. This vulnerability affects Java deployments running in a client sandboxed. You see there, it says web start applications or sandbox Java applets. So to me, I don't see the security manager used very often. I know it is used every once in a while, but I do see it broken out of every once in a while. To me, the most impressive part about this is not that somebody bypassed the security manager, but that in the year 2021, someone still found a way to run a Java applet. I'm actually more surprised to see the usage of an applet than I am to see a security manager bypass. Because the security manager architecture itself, this is something that was introduced back in about 1996. And you see that screenshot up there with I don't know if that's Windows 95 or 98, but they developed this form of portable code using the NP API, which was literally the Netscape plugin API. Netscape being that company that was I think the first or second web browser from Mosaic. So really long time ago. And there was a little bit of usage of the security manager in non-applet applications, but very few people would use it to defend their backend systems. And my involvement from it, I write articles for InfoQ. So when they announced that they were deprecating the security manager, I said, well, this is something I'm going to cover. I'm going to look into this. I met more people who used the security manager in that 6-week period between the time I wrote the article, OpenJDK proposes security manager deprecation. There was a 6-week time where I met more people who use the security manager than I had in 10 years of working in the application security field. So the usage of it, yes, there are some people who use it, but it's few and far between. And while I like the things that those people are doing, it's kind of time to move on to some other features and better capabilities. Because the other thing about it is that when you secure something, you need the context of the things that you're securing. And if you don't have that context, it's really hard to produce an active defense. For example, anyone who's on this Jug meeting, if you use Tomcat or JBoss, do you know what files you should put in an allow list? I sure don't know. What does Tomcat and JBoss need? I don't know. They need whatever they tell me they need. Do you know what classes your framework deserializes? The deserialization filter has nothing to do with the security manager anyways. It was introduced independently. But let's pretend they work together, which they don't. It's, again, information that you don't have that you couldn't put into a policy file, which doesn't go into a policy file anyways. Otherwise, let's say you want to defend your etc password file. You're on a Linux system. You know that's a sensitive file. You want to be able to defend it. Is it safe to access that file? Well, the truth is it's not a yes or no question, which is what the policy file allows. You don't know if it's a yes or no question. So should you be able to access etc password? Yes, if the application needs it. Like if Tomcat or JBoss needs to authenticate a local user, Sure, go ahead. That's what it's for. But you should not allow it if some user has managed to inject their own string into the file constructor command or the file constructor argument. Otherwise, then it means that somebody's trying to do a file injection and they're taking access to random files on your system. The security manager, however, is just, am I allowed to access this? Yes or no. Which library can ask it? Can ask it? It's not the library, it's the action, it's the context, it's whether the user controls the input. OGNL is not vulnerable in itself, so its permissions, go ahead and do whatever you want. However, the problem with OGNL was when user input hit OGNL and caused it to do other things. So you don't need to sandbox the OGNL, you need to sandbox the way that it accesses data, which was not a part of the security manager configuration anyways. Otherwise, there's another vulnerability in here. I ended up not including it in the original part. It should be in the speaker notes, I think, if you see it. There was a vulnerability that GitHub security researchers found in the RPC framework called Apache Dubbo. But if I want to go to secure Apache Dubbo and prevent the remote procedure calls from attacking my system, I can't do that because the JDK has no concept of Dubbo. So it's really hard to create a policy file that secures this RPC framework that from context that we don't have. So in order to provide effective security, you need something that can evaluate these contexts and not just say, can I do this? Yes or no. Can I do this? Yes, if the following conditions are met. All right, now I want to go through, and we've talked about different attacks that are going on in Java applications. We've talked about improvements that are going on in the JDK and have gone on since JDK 8 and 17. Now I want to give some key active takeaways that people can do in order to better defend your Java applications from different attacks and just get a really good, really strong security posture in place. So the summary of the three easy steps is: 1, continually maintain a patch cadence with the JDK and libraries to a reasonable amount of your ability. 2, you can shrink the JDK's attack surface, which reduces the opportunity for different attacks to come in. And 3, you can actually instrument your applications to catch custom code issues that are unique to your own applications. Now, if we look at the patch cadence, the core Java platform itself, the JDK that you get from either Oracle or Azul or Adoptium now, they tend to produce a security patch about every 3 to 6 months. So the majority of the players that produce JDKs, there's a new JDK about every 3 to 6 months. Upgrade, you don't have to do it right away. Nobody's going to come after you and start yelling and saying, hey, you're a day out of date. Just try to do your best with keeping up with this 3 to 6 month cadence to patch your JDK. If you miss one, if you're a little bit behind, I understand. We can't patch things all the time. Just do a good job of keeping up with periodically patching the JDK. For your libraries themselves, you'll want to periodically upgrade those libraries unless you know that you cannot. If you have your project hosted in GitHub, they have a nice tool called GitHub Dependabot, which will actually submit pull requests to your project to update those libraries. And the reason that you want to update those libraries is that you don't want a common vulnerability and exposure, any type of known risk, to come out and hit that library, and then it turns out you're multiple years behind. The comment that we had earlier at the beginning from the Chief Information Security Officer of the US Air Force, he was railing about GitHub or Atlassian including libraries in their project that was like 6 years old. It's time to upgrade some of these libraries. You don't just take a library and say, we certified on this version a decade ago, and by God, that's what we're going to use from this point out. You want to periodically update these libraries for 2 reasons. 1, security researchers tend to find vulnerabilities inside of older libraries. So the longer you keep an old library around, the more likely someone will have found a software vulnerability in it. 2, it's generally more fun and self-fulfilling to work with newer libraries and to take advantage of newer features. And if you let a library lag for a really, really long time, it's probably going to drag your whole project down. And you might end up with a case of, well, I can't upgrade to Java 17 because I need this version of this library from 12 years ago, and I have all these reasons. But if you periodically upgrade your libraries, not only do you get a better security cadence, but you get a project that's more fulfilling as well. Somebody who didn't do this, a couple years ago, there was a vulnerability in Apache Commons collection. The same deserialization vulnerability that hit Oracle WebLogic hit a large United States consumer broker called Equifax. What happens was they knew where they had a version of Commons collections. They didn't patch that vulnerable library, and someone started attacking it using deserialization attacks. The same thing that you can get if you download Why So Serial. Please don't use it on other people for projects that aren't yours. But attackers started attacking Equifax, and they took over the system, and they stole huge amounts of US customer data. And what happens was, not only did Equifax get into, and not only did they have their vulnerable application where somebody was stealing their data, they got a huge number of fines against them. You see the link here, the US Federal Trade Commission, which is not a group to mess with. They are a serious group. Equifax had to pay them about $575 million in addition to the amount of money that they had to pay to recover from the breach. So the fact that they didn't upgrade an old library, attackers found a vulnerability in that library and attacked them, not only lost them their data, they got fined a boatload of money in addition to it. So if you have older libraries, go ahead and upgrade them. If you can, submit a pull request. Just periodically get in the habit of updating these libraries. And the more you can automate, the better off you are. Another thing that you can do is shrink the attack surface of your JDK. Because we have modularity now, it's possible to shrink the amount of data that your JDK even uses. And when you do that, what happens is people can't attack modules that aren't there. So if somebody wants to issue an XML attack against your application for whatever reason, maybe they found a path to be able to call commands in java.xml. If you don't have java.xml, they can't attack you. So there's less to attack, which means it's less likely that somebody's going to hit something. So what you can do in order to shrink the attack surface is there's two tools that you can use that have been there since Java 9 and are definitely in there in Java 17. Those tools are JDEPs, which is Java Dependency Analyzer, that you pointed at your application's binary, and it will look at all of the bytecode, and it will pick out the JDK modules that you use. The second that you can do is a tool called Jlink, and what Jlink does is it creates a custom JRE for your specific application. It takes the full JDK that you're probably building with, and it creates a separate independently deployable artifact that you can use to push to production. You put that Jlink into a container, you put it on your core server, you now have something that you can deploy that's specifically custom to that runtime image that you have. So what you'll get if you use JDEPs and Jlink on your application is you'll have a fully deployable standalone instance of the JRE that's at whatever patch level you provided, hopefully keeping up with the patch cadence, that doesn't have java.xml, that doesn't have java.compiler, that doesn't have java.management. So if anyone tries to attack those things, you can't attack what isn't there. The last piece that I have, which is one of the ones that I tend to use rather well, is I use a feature called Security Instrumentation, which helps weave different security sensors into an application. And the reason I use this is it allows me, while I'm testing the application, to just gather a lot of security metrics and telemetry that's custom to my application at about any level of the stack that I want. So because instrumentation works with all libraries, I can go and I can extract data from my libraries, I can extract data from my custom code, and because it monitors how the application executes, I can understand how these things fit together. So by putting the Java agent with a security sensor in there, I can catch things like, what cryptographic APIs do I use? What algorithms am I using for data encryption, and are any of those below different current security standards? I can also track things like, what does the application do? Does any user input that comes in from like a web framework, Does it get encoded or decoded in any way? And does it make its way to a different security sensitive function, such as runtime.exec or a SQL query? If I have instrumentation watching those inputs and monitoring the data flow through my application, I can catch when that data makes its way to an unsafe function, even if that function is not attacked. So it turns my regular usage into security usage. So rather than me constantly waiting or saying, well, I don't know how to do a security assessment of my application, you can gather security intelligence from all of your execution. And the best part is you get security benefit, you get security intelligence for things that are in the JDK as well as on top of it. So if you want to see things like what happens with my Commons OGNL, a security instrumentation monitoring agent can pick that out, even though it's not in the JDK, because it has the ability to understand what's OGNL, what's JSTL, what are these other libraries that are security sensitive that are used by applications. And the sensor goes in and the system just watches itself. So it's security without having to go get an expert or having to get somebody else from a team. So it's something that you can all do in your Java applications at any time on a self-service form. And one of the other reasons I like this is we regularly catch these zero-day vulnerabilities or different flaws just right out the bat because we have security sensors in place. So this is also what I do on a regular daily basis. So for the Atlassian attack that came in, you see there was a mass exploit of Atlassian Confluence. And it turned out on day one, we were watching that. We don't use Confluence, so we weren't watching it at the time, but our agent had all the intelligence in place to be able to detect it and pick that out. For the WebLogic deserialization flaw that was going out, it was a 0-day in WebLogic at the time. And when we went to look, we said, wow, if we used WebLogic, we would have picked out that software vulnerability. So because the security sensor has the intelligence to look out for deserialization flaws, and because the security sensor has the context to look out for runtime injection flaws and OGNL injection, it's able to pick out the fact that OGNL in Atlassian Confluence is executing in an unsafe way. So it's nice to have this security intelligence hooked in during the test phase, because then all of your regular tests and execution become a security test. And just like you'll get performance data, you'll get security data coming to you from how your libraries are used. So with that, I want to wrap up the talk. If anyone at the Jug wants to have a different conversation about your project or organization, you just want to talk about the security of an application, I'm really happy to do that. You can just shoot me a note through any mechanism, and we'll jump in and talk about your project. It's not sales calls. I don't really like those anyways, but if you want one, sure. The company I'm at is called Contrast Security. We make one of those security monitoring agents that you can just hook into an application that gives you the full security context to understand the security posture of your application. And if anybody wants to reach out, there's a couple different ways. I'm on Twitter. My handle there is @Koslow, which is just my last name. There's the Fujay podcast that goes on Apple. We'll probably be doing a new episode of that in a week or two. And a number of articles at InfoQ. And beyond that, to keep your JDK, the security of your Java applications up to speed, just update your JDK dependencies, shrink your JDK to reduce the attack surface, and put a security instrumentation agent there to catch your custom security vulnerabilities.
So thank you, Eric. It was really informative talk. Those who are watching and enjoying this session, please, if you have any question, feel free to ask now. Floor is yours. And while you were asking questions, let me introduce another guest, Christian. He is a senior director. I'm gonna add him now. Let's see. Hey, Christian. Let me introduce a little bit about him. He is a senior director of open source project at Azul and Apache NetBeans PMC chair. He is going to talk about Fujay. So it's a friend of OpenJDK. He is going to talk a little bit about it. Let's see. Christian, the floor is yours.
Hopefully you can see my screen. Yes, right?
I just stopped sharing mine. There we go.
Okay. You can see my screen, I hope. Fujay.
Yes, we can see your screen.
Okay. Hi, everybody. My name is Geert-Jan. Thank you for attending this session. Thank you, Eric. Thank you, Basler. So the background to the session, very briefly, just 2-3 minutes, is that a site has been created over the past year called Fujay, which stands for Friends of OpenJDK. And if you enjoyed the session, then surely you are a friend of OpenJDK, so the O and the O of OpenJDK. Fujay.io. Eric mentioned an article about SolarWinds hack. You can find that article on Fujay. Basler also has content on Fujay since recently. You'll find the podcasts that Eric referred to. One that I really enjoyed especially was one with Dr. James Gosling, the founder and creator of Java. There's an amazing podcast there about embedded Java, including Johan Vos from Gluon. But there's a podcast here on Jakarta EE, and there's an introductory podcast, and there's a great one coming up on the different OpenJDK distributions. What Fujay is about really is it's a central place for anyone interested in keeping up with the latest Java developments. So there are a lot of changes. Every quarter there's a new update, and then you might wonder what is actually in that update. And also there are major releases, a lot of releases since Oracle took over Java. And this site provides you an overview of all the fixes that have gone into those releases and lists of the different OpenJDK distributions, because Oracle produces its OpenJDK distribution, but Azure does too, and Amazon does too, and Red Hat does too. And all that information you'll find on this site. Every day there's a new article. So there is articles from people throughout the Java community. And you can see a list of all the authors here. Many people from all over the Java community, and maybe you want to get involved too, in which case there is a Twitter handle, of course, so please follow Fujay on Twitter. And what there also is a Slack channel. And if you would like to join the Slack channel, it's a great place to be. A lot of discussions going on all the time about the latest state of Java, how to get involved in Fujay, about the podcast, and about this virtual jug tour that we're doing finally. So this is what we're doing to promote Java 17. And Eric's talk is one of these on the tour, and there's several more coming up. So if you would like at your school or college or company or wherever to hear about what's going on with Java, we'd love to provide content and help you keep up to date with what's going on in the Java community. That's what Friends of OpenJDK is all about. Thank you.
Thank you very much, Christian, for introducing us this wonderful platform where we can definitely look into and learn a lot of interesting stuff. Thank you very much for joining us. All right. So Eric, I guess we have 1 or 2 questions. We are almost over the. We're almost close to our 1 hour session. So we'll take 1 or 2 questions and then we'll close. Hopefully, I'm sure everyone enjoyed this session very much. So one question I have over here. Let me ask that question. So it's
I think we're sharing a screen now. We got like an infinite recursion into the restream system.
Okay, let me close that.
There we go.
Okay, perfect. So yeah, now it's looks good, I guess. The question is, what are the steps a Java developer can take to learn more about security and harden our application and get overview of the current threat models and attack surface?
Yeah, so the way that I would do that, the way that I'd look at the security of an application is there's 1,000,001 different security tutorials that you can read. But I always have trouble just looking at generic information when there's no context for how that pertains to me or my system. So while you can go to a website like OWASP and you'll learn about what the different vulnerability categories are, because there's like the OWASP top 10, or you go to SANS CWE that has the CWE top 25, they don't tell you what the security risk is to your specific application. So what I would do is just take a security instrumentation agent, which is one of the things that Contrast has, that will just go in and it will gather like what vulnerability categories are actually in your application. And then you go and you learn like, oh, that's what that is. Like, you know, it'll pick out and it'll say you use weak cryptography. And you'll say, well, why is MD5 weak cryptography? And to me, that's a lot more interesting because it's actually relevant to my application. Otherwise, like I used to get people all the time when I was in the securing the JDK, and they'd come to me and they'd say, let's talk about the risk of cross-site scripting. Cross-site scripting is a web flaw if you produce web applications and you produce the HTML front end. But if you're working on the Java platform itself, or if you're working on a back end like Kafka Stream, you don't care about cross-site scripting because you're not a web application. So you can certainly go learn like random security information, and that's great, but you need something that's relevant. I got a bookshelf. Yeah, here we go. Yeah, so I've got my particularly helpful is this book called Threat Modeling, because it breaks down the context of what you look for in an application. And certainly the book is thick if you want, so you'll get a lot of good information. But the gist is you want to focus on things that are relevant to you, because worrying about threats that can't happen is just there's too much to worry about. So you just end up in this like hemming and hawing about risk, which is really obnoxious, but you got to focus on things that are relevant. A way that you can shorten that even further is there's literally a threat modeling card game that you can look at an application and you just pick out these cards and it'll say like, you drew, you know, the 10 of spoofing. Come up with a way that this can occur in your application. And if you just play a couple cards against your application, you're literally threat modeling the thing, and it's super easy. And like it does such a good job of focusing your attention on the things that are relevant to you that you now have some focus and scope.
Thank you. That's a great answer. I think Mr. Arno has a questions for you. Yeah.
Yeah, actually, Eric talked about it to some extent. So I was actually just asking if Eric can provide us any kind of recommendation for any kind of tool that developer can use for this detecting things. Like, I remember, like in a small team, when we are working, it is not that we can spend a lot of time in security, right? I mean, especially the application developer, they usually don't put that much effort in this kind of thing, but like some kind of sometimes just some tools in build system that help to detect. Like in our company, it is a very small company. We just use a Maven dependency check, OWASP dependency check, and it by default detect if there is any vulnerability in the dependency. So yeah, I mean, if you can provide us anything.
Yeah, so the tool that I use is, I work with Contrast Security. So I think this is a form here to sign up and get access to the free community edition account, which will give you an agent that you can just weave into your application. And then it'll pick things out and it'll just tell you like, here's a couple vulnerabilities in your application. So all you do is you add this -Java agent :contrast.jar thing, and it'll just hook in and connect up. And you get security information about your application, because otherwise there's actually a talk that I'm doing. I got to record it later this week, which is called Securing Your System While Getting Your Regular Work Done. It basically covers the context that software engineers are not security engineers. You don't have an infinite amount of time to constantly spend like hemming and hawing about risk. You got to focus on things that are there because you're measured on actually delivering features and software. So it's just how can I get security done while getting my regular work done?
Yeah, good.
Thanks. So we have a couple of appreciation, comments. For example, people say, it was a nice topic, very informative. Informative. Thanks a lot for Jack Biddy and Eric. Special thanks. So yeah, there are a lot of interest. A few people also said, thanks for the amazing sessions. They enjoyed. That means.
Yeah. I mean, I think
yeah.
the thing is, I mean, probably developers don't research by themselves about the topics a lot. But by Eric's session, I think our community, they will be exposed to more like of things, right? I mean, the things Eric talk about in each slide. If you can just Google it, you can learn a lot of things, right? I mean, so yeah, it is a really great informative session, I would say.
I think the question with this topic is it's so broad, and as Eric says, you have only so much time in your day to do the things that you need to do. How to choose which areas of security to focus on is the challenge, really.
Yeah, that's the area that I think the majority of people, especially new entrants, sort of slip up on, is they start worrying so much about the risk of what can go wrong that they forget about the relevance of these. And the fact is there's certain things that can happen and there's certain things that can't. I've regularly been a part of conversations where people say, assume my system is compromised and assume somebody's executing local commands. They could attack my Java application like this. And the gist is, it doesn't matter. If somebody's literally executing commands, it doesn't matter if your application's secure or insecure because they don't need to go through it anyways. So for security, it's staying on the focus of what does my application do? What assets do I have? And what's the risk exposed to those assets?
Yeah, that's definitely it is. And
I think you should. I think, Eric, you should write an article on Fuji called "A Common Sense Approach to Java and Security."
It would probably save me a lot of conversations. Yes.
And one of the things that I got from your speech is if you keep updating your Java, that's also removes a lot of cases. Yeah, so keep updating. We have
that is very basic now. But that is very basic, but ignored by a lot of developers and organizations.
Regrettably, yeah. So what happens is the longer something has been around, the more people find vulnerabilities in it. Like all the vulnerability, like the exploit tools that I and other guys have, they attack things through knowns. So if you're upgrading, and something's fixed, then the tools can't hit you. So you just get in the regular upgrade cadence, and all of a sudden you've knocked a lot of these tools out. So they just, like, regularly speaking, attackers don't go after you specifically. That's called like spear phishing or like specific attacks. Frequently, they're just crawling around the internet looking for any systems they find that are vulnerable. And if you're patching your stuff, they're probably just going to pass right on by. There's a joke of, I don't have to outrun the bear. I only have to outrun you. Similar style.
I mean, we have now Java 17 released this month, right? But I'm sure majority of the application is still in Java 8. I mean, people hardly want to, upgrades. So this month in my company, I tried to push to upgrade. They have upgraded into 16, which is great. Hopefully, we'll be able to upgrade in 17 in few months. But yeah, I mean, we should really focus on upgrading the Jdk. That will solve a lot of problems.
Yeah. So actually, to that point, within each Java major version, whether it's 8, 16, or 17. Each of these different main lines or versions has something in it called the security baseline, which is you'll find like Java 8 update, 100, Java 8 update 102. Mm-hmm. And for each version, let's say you want to stay on 8. Let's say you have to do it. You want to keep a patch cadence with this security baseline. and that you probably wouldn't use Oracle Java 8 anymore because they don't provide 8s anymore, I don't think. So you'd switch to a different JDK vendor if you had to use Java 8, and I think Azul actually does still provide JDK 8 updates. So you'd switch to that, or you'd switch to somebody who maintains the security baseline there. And if you want to find out what the baseline is, I think it's an XML file, or it might be JSON now. You just search for, Java security baseline, and you'll find out what it is at any given time. The baseline changes each time a new version comes out, which is about every 3 months.
That's great. So thank you, everyone. And I guess Christian wants to share something. Yeah, let's. This is the 4J 4J Twitter handle, and this is the page where you can get all the tips and tricks daily. So you can definitely follow.
Every day there are new tips and tricks about Java on this Twitter handle, so it's a great one to follow.
All right. So thanks, everyone. And thanks, Eric. Thanks, Christian. And thanks, Arno Abdullah Al-Mamun, for joining this session. It was really wonderful, and we all enjoyed. Thank you very much.
Thank you, Liz.
Thanks for having us.
Thank you very much.